Okay, in this video we're going to solve quadratic equations when they're in factored form. And so what factored form is for a quadratic is it's this form right here. We've got, a leading coefficient, and then it's kind of taken this form where it's really the product of a couple of binomials. And you can see an example of a quadratic in factored form would be this one right here. So we've dealt a little bit with vertex form, we've dealt a little bit more with standard form, but I really want us to focus in on factored form. And so the example that we're going to work is we're going to solve this equation. So we've got 0 equals, and we've got x plus 4 times x minus 2, which is a quadratic in factored form. And so I always bring up our related function would be this. Now we've already learned that to solve this quadratic equation, we can graph the related function and look for the x-intercepts. Okay, so the x-intercepts of this function will be the solution to the equation up top. Okay, so that being said, I'm going to take us down a little rabbit trail that's going to help us in a minute. So this is going to seem kind of random, but I want us to see something important about the relationship between these factors and between that and the whole quadratic. So if I were to look at this factor right here, like it were its own function, it would be this. It would be the function y equals x plus 4. And if I were to consider this factor like it were its own function, it would be the function of y equals x minus 2. So we can see that these are called the linear factors because if I were to graph them, they would make linear functions. Y equals x plus 4 is linear, and y equals x minus 2 is linear. So what I want to do is I want us to graph each of these two linear factors on the coordinate plane, and then I want us to graph our original quadratic on the coordinate plane, and I want us to see about the relationship between those three functions. So you can graph that. I've got on the next slide, so if you want to take some time to graph it, you can pause this video, but I'm going to go ahead and advance. Good, and now that we're here, here's what it looks like. So we've got the graph of our parabola, and then we have the graph of our two linear factors. And so what's the relationship between these? What I hope you're noticing is that they have the same x-intercepts. Okay? And so in this case, the x-intercepts are -4 and 2. Now why that's important is this, okay? And I'm going to kind of try to tie this all back together. Remember, we're trying to solve this equation. To solve that equation, we do that by graphing the related function and looking for its x-intercepts. If the x-intercepts of this function are difficult to find, we might make it easier on ourselves by instead finding the x-intercepts to these two individual linear equations. If I know the x-intercepts to these linear equations, I then know the solutions to the original equation we're trying to solve. So let's do an example so we can put it into practice. Okay, if you want, you can pause the video, but I'm just going to go ahead and work it. So here's a quadratic equation we're trying to solve. Our related function is y equals x minus 6 times x plus 1. That's our related function. If we can find the x-intercepts to this function, we will then know the solutions to this equation. We could just graph the function and look for the x-intercepts, or we could practice our new skill, which is look at these linear factors like they're individual equations. If I can find the x-intercepts to these, then I know the x-intercepts to this, and therefore I know the solutions to this. Okay? So I'm going to find the x-intercept, you substitute 0 for y. So I have 0 equals x minus 6, and 0 equals x plus 1. I can solve each of these equations. I'm going to add 6 to each side here. I'm going to subtract 1 from each side here. And so my solutions here are going to be x equals -1 and 6. Now to check it, I'm going to pull over my graphing calculator here. and I'm going to graph x minus 6 times x plus 1. And let's see what the x-intercepts are here. It looks like my x-intercepts are -1 and 6. Therefore, our strategy that we just used here is good. Now, let's go ahead and attack this next one. This next one's where it gets a little bit tougher. Here's the equation we're trying to solve. Therefore, I can consider the related function y equals 2x minus 3 times 4x plus 9. If I can find the x-intercepts of this related function, then I will have solved the original equation. To find the x-intercepts, I want to consider these two linear factors. And if I can find the x-intercepts of those factors individually, I'll then know the x-intercepts of the quadratic, which will give me the solutions to the original equation. So the way we find x-intercepts is we substitute 0 for y. I'm going to add 3 to each side of this equation and then divide by 2 to get x equals 3 halves. And then I'm going to come over here and solve my other one. I'm going to subtract 9 from each side. And then I'm going to divide by 4 to get x equals -9 fourths. So our solution set here is x equals 3 halves and x equals -9 fourths. So really, I think that ends up being like 1.5 and -2.25 or something. But why our current strategy is important is let's go back to the calculator to see. I'm going to change this to my current problem, 2x minus 3 times 4x plus 9. Well, if we were going with our old strategies, graphing it and looking for the x-intercepts, we'd see our parabola doesn't cross the x-axis at integer values or at whole numbers. So it's really hard to look and tell, where is y 0? Well, I think it might be somewhere in between 1 and 2 because our y goes from being a negative to a positive, right? We can see that. And then it's probably somewhere in between -3 and -2. So I can look on my table and kind of guess, and I can look at my graph and kind of guess. But what we've learned is so important for this reason. If I take these linear factors and look at them like separate equations, I can find those solutions individually by substituting 0 for y. Then I don't have to guess. I can get my exact answer.